Welcome everyone. Let's dive right into this explainer where we are taking a progressive, step-by-step approach to truly understanding Cambridge IGCSE mathematics. Today, we're building the absolute bedrock: calculations, fractions, and calculator proficiency. Look, whether you're feeling just a little bit rusty or you really want to bulletproof your exam technique, mastering these core principles is absolutely essential. So let's get into it.
Okay, before we jump into the theory, I want you to try solving this exact question in your head. 4 plus 6 times 2. Have an answer? Well, if you got 20, don't sweat it, but you've just fallen into a classic order of operations trap. It is literally one of the most common pitfalls we see examiners catch students on, but by the end of our time today, you're never going to make that mistake again.
So here is our roadmap for today. We're going to establish the ground rules with the order of operations, understand fraction theory, visualize complex fraction math, translate those over to decimals and percentages, and finally, master your exam calculator. All right, kicking things off with Section 1, Order of Operations. These are the fundamental ground rules of math. Think of these rules as the traffic lights of mathematics. Without them, everything just crashes into each other. Going back to our starting question, this brilliantly illustrates the rule you absolutely must do the multiplication first. 6 times 2 gives us 12. Only after that's done do we tackle the addition, adding the 4 to get the real, correct answer of 16. This hierarchy, where you handle multiplication and division before even looking at addition and subtraction, is entirely non-negotiable. Moving right along to Section 2, Fraction Fundamentals. This is all about understanding pieces of the whole.
Let's talk about how we actually transition from whole numbers into pieces of a whole. A single unit broken into equal parts always consists of two vital numbers. You've got your numerator on the top, which tells us how many parts we actually have, and your denominator on the bottom, telling us how many equal parts the whole is divided into. Now, we've got a perfect contrast here of our two main fraction types. On the left, a proper fraction, like 3/4, where the top is nicely smaller than the bottom. But on the right, an improper fraction, like 9/2. Notice how that improper fraction is top-heavy. Recognizing this is absolutely crucial when we start doing actual calculations, because, well, they behave a bit differently.
And then, of course, we have the mixed number. It's exactly what it sounds like, a combo of a natural whole number and a proper fraction. 4 1/5 is a classic example. But hey, here's a massive pro tip for your exams. When you are dealing with mixed numbers and complex calculations, it's almost always so much easier to just convert them back into improper top-heavy fractions first. Trust me, it makes the math way cleaner.
Which brings us to Section 3, Visualizing Math. Let's look at adding, multiplying, and dividing these fractions. You see, it's one thing to know what a fraction is, but it's a whole different ballgame knowing how to combine them. The absolute golden rule here is that you cannot simply add numerators and denominators together. No way. If you want to add 3/11ths and 5/11ths, you can only do it because those bottom numbers already match. They are both speaking the exact same language of 11ths. So you just add the top parts, 3 plus 5, giving you 8/11ths. If the denominators don't match, you have to use equivalent fractions to force them to match before you do anything else. Now, multiplication is a bit of a different story, and visualizing it like 3/4 times 2/3 is actually pretty fascinating. Just imagine a rectangle. If you split it into 12 equal parts, shade 2/3 of it, and then shade 3/4 of that already shaded area, you're left with 6/12 of the total rectangle being double shaded. This visual perfectly proves why our multiplication rule works. We just multiply the numerator straight across. 3 times 2 is 6. And the denominator straight across, 4 times 3 is 12. And 6/12, that simplifies perfectly down to 1/2. Okay, before we tackle division, we really need to introduce a fun little concept. Understanding the reciprocal is basically your secret weapon. The reciprocal is obtained when 1 is divided by a number, but honestly, practically speaking with fractions, you just flip it. Yep, the reciprocal of 2/5 is simply 5/2. Why does this matter so much? Because dividing fractions is the exact same mathematical process as just multiplying by the reciprocal. Let's test that out. The question, how many 3/4 go into 3/8, is written out as 3/8 divided by 3/4. So instead of panicking over the division part, we just keep the first fraction and multiply it by the reciprocal of the second. So 3/8 times 4/3. Multiply straight across. 3 times 4 is 12, 8 times 3 is 24. And 12 over 24 simplifies neatly and beautifully down to 1/2. Simple as that. Now for Section 4, Decimals and Percentages. I like to call these fractions in disguise. Seriously, just think of decimals and percentages as fractions wearing a disguise. They are literally just fractions with special, standardized denominators. Notice how the place value completely determines the decimal's meaning. Looking at 3.27, that's 3 units, 2 tenths, and 7 hundredths. It is perfectly mathematically equivalent to 3 and 27 over 100. Conversely, 0.038 is simply 38 over 1,000. Once you start seeing decimals as just fractions with denominators of 10, 100, or 1,000, they become so much less intimidating. You can consider this your ultimate cheat sheet. Percentages literally translate to out of 100. So if you want to turn a fraction like 3/5 into a percentage, you just use equivalent fractions to change the denominator to 100. Multiply the top and bottom by 20, and boom, you get 60 over 100. That is exactly 0.6 in decimals and 60%. They are all mathematically identical. And finally, Section 5, Calculator Mastery. This is where we bridge the mathematical theory to your actual exam tools. You can know absolutely all the theory in the world, right? But if you enter it incorrectly on your physical exam calculator, you're going to lose those marks. Notice this dedicated fraction button on the Casio calculator. When you encounter a complex calculation, say an entire expression like 90 plus 38, all over a denominator of 4 to the power of 3, always, and I mean always, start by pressing this fraction button first. It sets up the structure visually on your screen right away so you don't mess up that order of operations we talked about earlier.
Next up, you need to confidently find your exponents. Whether you're rocking a Casio or a Texas Instruments model, locating your power button, which you can see here side by side, is absolutely essential. You'll need this specifically for inputting that denominator of 4 to the power of 3 correctly, without, accidentally just typing 43.
And here is the final beautiful result. By starting with the fraction button, typing your numerator, and then properly using your navigation pads to move down to the denominator to type your exponents, your screen should look exactly like the textbook. Both calculators will perfectly process the internal order of operations for you, rewarding you with the wonderfully clean answer of 2.
Well, that brings us to the end of today's explainer. You now have the fundamental ground rules firmly in place. But I want to leave you with a bit of a provocative thought to chew on. Consider how mastering these numerical basics, fractions, decimals, and operations, is really just the crucial first step. How are you going to apply these exact same rules when the numbers are replaced by variables and these fractions reappear hiding inside complex algebraic equations? That, my friends, is where the real challenge begins. Keep practicing your foundations, and we'll see you in the next explainer.